Hi guys, I'm Darren, and if like me, you've been stuck in lockdown for what seems like an eternity, and I've forgotten how to check over a plane to make sure that iNav is set up right. So I've created a checklist. I'm going to go over it in the video just so that hopefully you guys have a successful flight after lockdown. Alright, so this is my beaten old mini AR wing. I've done a fair bit of work to this since I last flew it. I've completely wiped the flight controller, put everything fresh on it. I've updated the receiver to access and using F-port now instead of S-bus. I've moved the flight controller back so I can fit bigger batteries in. So I just want to test everything to make sure it's working. And likewise, the last week or so I've been setting up planes for friends, and it was even more important that I made sure that theirs work fine. Right, I've created a checklist which I will be putting up on my site and the iNav fixed wing group so that everyone can get access to it. And I'm going to try and do it so that we can just sort of tick stuff off as we go. If not, I'll make it so it's just a downloadable document or something like that so that it's easy to look at. What I'm going to do is, obviously the first step, we want iNav. So let me just connect up. Right, so let's connect up iNav. Right, there we go. Now the first thing on the checklist is, have you calibrated the accelerometer? Obviously, you really want to do this before you build the plane. Do it on the bench when it's out. But yes, one thing you just need to get checked off is make sure that you've calibrated the accelerometer. That's the first thing to check. So the next thing that we're going to take a look at is the ports page. So we just want to make sure that everything that we've got connected is assigned. So we have our serial RX, which is quite important. I have SmartAudio on this, and of course GPS. So we just want to make sure that everything is set up on the ports page. Then we can head over to configuration, or you can look at the bars at the top and just make sure that the barometer is working if you have one, which obviously is recommended for fixed wing on iNav, and other things like the VTX. So for that we need power. So I'll be using my appropriately sized battery for a mini AR wing. So we can power on. Let's power on the video. Let's make sure we're on the right channel. There we go. So that's better. Now we can see. So the video camera is working. Right, so we can see obviously our VTX and our camera is working. We can go through and check different OSDs if we're cycling OSDs.
Manual tuning off.
What else can we check? We can make sure that there's no system messages that shouldn't be there for invalid commands or any other things that will cause you issues. So we can check all that out on the OSD. Next thing to check, flight modes. Oh, sorry, VTX. Obviously, if you've got SmartAudio, make sure that that's working. So we can see it's on power level 2, power level 1, power level 4. Yeah, so SmartAudio is working, which is all good. Right, so flight modes. So iNav 3, this will be a much better organized page. We'll be able to see like the modes right next to each other. So it's just basically go through this, make sure your switches coordinate with what you want to happen. So it's not something I'm going to go through. I've checked that this is all fine. So obviously the important thing is make sure your arm switch is in the right position, and obviously your flight modes, that sort of thing. So that's checking the modes page. The next thing that you want to check is the orientation and movement. So we'll go to the setup page. If you reset the Z-axis, it basically puts the back of the box towards you. So if we lift the nose, you should see the top lifting, dip the nose, bottom lifting. So that's all fine. We just need to obviously make sure that that works before we go on and check some of the next things. So Next, we'll hop into the receiver page. And if I get the transmitter, you want obviously all the way right to be 2000, all the way left to be 1000, all the way down 1000, all the way up 2000, centered around 1500, and the same on both gimbals. If that's fine, then you're good to move on to the next step. Obviously, roll needs to control roll, pitch needs to control pitch, yaw, and throttle. If that's right, then we can move on to the next check, which is the mixer. So we just want to head here, make sure that the mixer is set up correct for our airframe. So we've got a flying wing, which is an elevon setup effectively. So we've got 50-50 distribution because it is a flying wing. Obviously planks or forward swept wings, this may be slightly different weights, but just make sure that it's correct for your model. So the next thing to check after that is we're going to go to the servos or the outputs page, make sure that motors and servos are enabled, you're on the correct protocol for your ESC, idle power set to 5% because it's standard ESC in this, and just make sure that that looks all right. And now we can actually move on to testing the control surfaces. So the first thing we need to do is put it in manual mode. And now we're going to just check. So if we pull back on the stick to go up, you should see both elevons or your elevator going up. Obviously down will need to go, or forward away from you is down. If we want to roll right, you should see the right elevon coming up and the left going down, or of course aileron if it's a regular plane. If we want to roll left, you'll see the left aileron or elevon coming up and the right one going down. So obviously you would check the rudder if you have one too. So we know that all that is fine. I should actually say do all this with your prop off just in case. It shouldn't spin, but it's something we can test. So if it all works well in manual, the next thing to do is put it into angle mode. Angle. So there we go, we're in angle. So we just want to repeat that exact same test. Again, if your control surfaces aren't moving correctly, I'm not going to show you in this video how to fix it. I have got videos on elevon mixing, which is the most difficult, but all you really need to do is, if you're in the outputs page, just reverse the servo that's backwards and it will sort you out. That's in manual. In angle, you want to repeat the test and it should do exactly the same thing. So pulling back on the stick, they should both go up. Pushing forward on the stick, they should both go down. Right on the stick, right goes up, left goes down. Left on the stick, left goes up, right goes down. If that's all fine, then that check is passed. We can move on to the next check, which is stabilisation. So for this one here, what we want to do is put the nose down and we should see elevators or elevons going both up. Nose up, we should see elevators or elevons going down. If we bank over to the left, we should see the left aileron going up or elevon going up and the right going down. And again, reversed, if you're banking to the right, you should see the right aileron going up or elevon going up and the left going down. If that's all good, you know your stabilization is correct. Obviously, if you have a rudder with stabilization, you need to check the yaw as well. So we know at this point our control surfaces are moving correctly on the actual flight modes, so manual and angle. So if angle's working, all your stabilized flight modes, the control surfaces are going the right direction. If manual is correct, then manual's right. If they're both correct, you know that the board orientation is correct and the receiver is also correct. And the control surface, the stabilization moving like that means that it's all right. So the next thing that we want to do is check the PIDs tuning page, and what we're going to do is go to rates and expo, and what we want is just some nice moderate rates for this initial flight. So if you think your plane can do 360 degrees per second, you don't need to put that. What we need is just some nice simple rates. And going forward in iNav 3, this is actually going to be the defaults for a tailless aeroplane. So a flying wing, plank, whatever, it will be these values for the rates. But of course, iNav 3 will have the automatic rate tuning, so it will set them perfectly for the plane. With 2.6, we will need to measure the rates and set them afterwards, but this will get us in the air and it won't behave too crazy and nothing will go wrong. So you're better having lower rates than the higher rates. So we've got 180 degrees per second, we got 90 on the pitch and 30 on the yaw. I believe on a standard aeroplane they're lower. I can find those out and put those in the video description. But that's what we just want to get a nice sedate setup for our initial flight. When you're measuring the rates, obviously measure it in manual mode. So you would fly a complete roll and a complete loop, and you would basically calculate how many seconds it took to do the roll. I mean, obviously, if it took half a second to do the roll, you would be looking at something like 720 degrees a second. Yeah, something crazy like that. So just use the video and the movement to calculate. Obviously, if you can't do full rolls or pitch movements, yeah, just bank right 45 degrees, then bank left 45 degrees. That gives you 90 degrees, and then you can obviously add a multiplier. Once you've measured that in manual mode, what you need to do is take 20% off of that. So we're using 80% off the full rates. So if we have a roll rate of 200 degrees per second, we'd want to put 160 degrees per second in this field. So that's just going over rates. So the next thing that we're going to do is take a look at feed forward. Now, I've already set this up on this plane, but to give you an idea of what you want to do, you stick it in manual. And then what we'll do is we'll do pitch first. So I'm going to do pitch up. So we'll see the control surfaces go up. And then what you do is you put it in acro or angle. So we'd put it in acro. What you want to do is see about 80% of the movement. So if it just drops down a little bit, I could probably add a little bit more feed forward to that still. But you want 80%, 80 to 90% of the throws in manual to be acro. So that's manual, so full throws. So we just want it to drop about 10 to 20%, and that's fine. And you do that then on the roll, and if you've got yaw, do it on the yaw as well. And that will get a decent base feed forward. So I just cycle the ESC. So that'll get a nice base feed forward to start the auto tune with. It's nothing too crazy, and it can calculate itself from there. So as I said, in pitch I could probably add a bit more, so I'm going to bump that up to say 90, do a save, and then we'll put it in manual, pitch up, acro, and you can see the difference. That's absolutely perfect. And we'll do the same on the roll, and that's fine as it is. So that's how you would adjust the feed forward. So the next thing that we need to look at is failsafe. Now we just need to make sure on this page that we've set failsafe, so we've got it set to return to home, and if just make sure that that's all set. Obviously we'll check the RTH settings a bit later, but first we just want to make sure that the failsafe is actually going to do what we want it to do. So the next thing to test is, does failsafe work? So switch off your transmitters. And what you're looking for is this parachute up here. If it turns red, it means failsafe has been kicked in. So it will do whatever you select on here. So in this case, it will be returning to home. And then if you switch the transmitter back on, as soon as it reestablishes the link, the parachute should go back to being grey. So we can see we've tested failsafe works on the bench. If you want to test it in flight too or at the field, there is a procedure on the iNav wiki for how to test that. But just by doing this simple test, we know that it is working. So next up, we're going to actually check the return to home settings. We're using failsafe return to home for our failsafe, so we need to just make sure that everything is working there. So what we're going to do is just check this and make sure that all the settings are as you would like them. So I'm using, at least with linear descent, I have a return to home altitude of 300 feet. I have a home altitude of 150 feet. So if you don't know what that is, it means that if you're below 300 feet, it will climb to 300 feet to return to home. If it's above 300 feet, it will not climb any, it will just stay at the altitude it's currently at. And this altitude here is just to make sure I clear any trees, but obviously it brings it down lower than this altitude, so it's easier to see the model. If you're in failsafe, you could have no video, so getting it a little bit lower to you for a line of sight landing is not a bad thing at all. I personally use climb before return to home. There's two different ways of looking at it. The way I look at it is if I'm flying low down near trees, which I am a fair bit, if you start turning, there's a very good chance you're going to end up in a tree. It's very unlikely that you're going to be flying towards a hazard. So having climb first just makes more sense to me. And Andrew Newton also brought up a very, very good point that if you're flying slowly and you're quite low down and you get a fail safe, if it tries to bank, it could be that it's so slow that it will stall the plane and crash. So it's better to get it climbing first. It can build speed up, then do the turn. But you know, this is depending on your situation. You may prefer turn first if you're always flying higher up, for example, so you just start coming back sooner. That's the biggest advantage of turn first, is you're coming back quicker and you're not wasting energy climbing away from yourself. Just make sure that your RTH settings are correct. If you're going to use auto launch, then obviously get a base launch setting in there. I've not actually set this up yet, but I have a video on how to do it. I will be doing another updated video shortly because there is a discrepancy with throttles. So that will be coming shortly. Hopefully now we can fly again. Yay. Anyway, back to the list. So we're pretty close to the end now. The other thing while we're on this page is we want to check the loiter radius. If you've got a bigger plane, obviously you want to make this bigger. This is currently set to 75 meters, so it's a 150 meter circle in the sky, which should be good for most planes. If you have got bigger planes, then you would probably need to go bigger. If you've got smaller things like the SAR wing, I could probably go smaller. But yeah, that's also going to be the new default in iNav 3.0, 75 meters. And we can also check some navigation stuff. So we've got cruise throttles. Obviously we'll need to tune this in flight, but we got a good base. So that should be everything on this page. And obviously don't forget to save and reboot. And the last thing that I'm going to check on here actually not the last thing, because I missed something out. I sort of briefly went over it. Obviously the second thing I went through was the ports page, and I've actually got a note for GPS. So what you want to do is make sure that your GPS is working. So you should have blue there, total messages should be going up, and make sure that you can get a 3D lock. So you want at least 6 satellites here, and the fixed type should say 3D. I'm not going to wait for mine to get a lock. I know that this one is working, but that's where you want to watch out for, is just make sure it's 3D there, 6 there, and the messages are going up. I've actually seen I can actually update that though. So that's on U block 7. That's strange. It should be at 10 hertz. Anyway, for more satellites, always enabled Galileo. Galileo is a European satellite constellation, but it will still go over other areas of the planet. So if you turn this on, you've got a good chance of getting more satellites. It won't actually do any negative impact whatsoever. Also, this nice time zone thing. So if you're in USA or Europe, you can have automatic daylight savings, and you can change the offset for where your locale is. So if you use the clock in the OSD, it will actually set the clock for you. So the last thing to check, now that we know that our GPS is working, is the OSD. So the first thing that we want to do is just make sure we've got a font. So open Font Manager and upload a font just to make sure that it's on the board and it's the latest version. And then make sure your OSD is set up correctly as you want it. Of course, you can have different layouts doing different things, but the one thing I would suggest is on the default layout, put either a plus code or GPS coordinates. There's a CLI command that means if you fail safe, it will go back to the default OSD. So it means you only really need your GPS coordinates on the default OSD, and it will flick to them if it fail safes. So that's quite a useful setting. Again, I'll put it in the description. So the default I only really use just when I'm switching it on, just to make sure that everything's working. Then I would have my regular flight OSD, which has got a lot less stuff on it. Then I'll have my sort of open flight OSD, I guess, so I can still see things like the battery, voltage, speed, altitude, that sort of thing, but most of it is open. And then finally I have the tuning OSD, which is based on the iNav Fixed Wing Group Pro Models OSD. I've just moved some things around so it's more consistent with my regular OSD. I've also got OSD off. So I'm going from the most information on screen, and each OSD is getting gradually less and less information until the OSD is off. Manual tuning. And then I've got my manual tuning OSD. Manual tuning. And yeah, it's easy enough. You just do it in the modes. So if we head to the modes, the way I've got the OSD set up is just slightly different. So default is the first thing, Alt 1, Alt 2, then a space, which is actually OSD off. So OSD SW, it confuses a lot of people. If it's in the blue tab, it turns the OSD off. It's not to turn the OSD on. And then the final alternate OSD, which is the tuning OSD, is last. Yeah, that's just how I got mine set up. But if you go through all these steps, then you should be good to go. Obviously, you can go further into it. So of course, you could set up adjustments, you could set up programming, you can do all that sort of stuff, but this is really just to make sure that when you throw the thing, it's not going to just crash and burn because we've forgotten something fundamental. But anyway, yeah, this video was about getting a simple checklist just to make sure that the basic functionality is working, and we should have achieved that. We can go flying with this and we'll be all good. So thank you very much guys for watching. Give it a thumbs up. Don't forget to subscribe if you haven't already, and click the bell icon to get notifications for new videos. Doing those things will also help get this video out to more people so they can learn about this as well. So thank you very much guys. Get out, fly your models like you stole them. Yay! And I'll see you on the next one.